The James Webb Space Telescope has once again opened the doors to a cosmic mystery. This time, by capturing what appears to be something both breathtaking and unprecedented. A faint, steady glow coming from Proxima Centauri b, the nearest known exoplanet to Earth. But this wasn't just any glow. To the astonishment of astronomers, the light patterns resemble the artificial glow of city lights. City lights, on another world? This is more than just a poetic metaphor. This phenomenon raises the tantalizing possibility that an intelligent civilization might be illuminating their world just as we do ours. Proxima Centauri b lies only 4.24 light-years away from us. It orbits its host star, Proxima Centauri, a red dwarf that is part of the Alpha Centauri star system. This proximity has always made it a focal point for those searching for alien life. But now, the lights observed from its night side have added a new layer of urgency and excitement to this search. These mysterious emissions were detected during one of the James Webb Telescope's recent observation windows, where its ultra-sensitive infrared instruments scanned the planet across several transits. As the telescope locked onto Proxima b, scientists observed something strange, a steady, narrow-band signal, reminiscent of artificial illumination. Such a signature could not be easily explained by natural phenomena like volcanic activity, auroras, or reflected starlight. To be clear, the signal didn't flicker like a star or burst like a gamma ray. It remained consistent, targeted, and persistent over time. The characteristics of this emission made it look eerily similar to what Earth might look like from afar. Our cities glowing in the night, revealing signs of technology and intelligent life. The discovery raises the question, what kind of civilization could be living on Proxima b, and how advanced would they need to be to illuminate a part of their planet on such a scale that it's detectable from light-years away? To understand why this is such a big deal, we need to consider the planet itself. Proxima b is slightly more massive than Earth and resides in its star's habitable zone, the region where temperatures could allow for the existence of liquid water. This makes it a prime candidate for hosting life. But that's just the beginning. Proxima Centauri, the red dwarf it orbits, is known for being extremely volatile. It emits powerful solar flares that could potentially strip away a planet's atmosphere over time. If Proxima b still retains an atmosphere, it would likely require some form of magnetosphere or protective shielding to survive such radiation, possibly hinting at natural resilience or even technological adaptation. Here's where things get even more interesting. Proxima b is thought to be tidally locked, which means that the same side of the planet always faces its star while the other side remains in permanent darkness. This configuration creates a scenario with one hemisphere bathed in continuous daylight and the other trapped in eternal night. Now imagine an advanced civilization living on that planet. If life evolved or relocated to the dark side to escape the intense radiation of the sun-facing side, it would need artificial light. That light, especially if it's consistent and widespread, might appear exactly like what Webb has just detected. Streetlights, infrastructure, or even massive energy arrays could produce emissions that mimic the glow we now see. Astronomer David Kipping proposed a compelling theory. What if we're seeing deliberate planetary-scale energy use? If these emissions correspond to areas that don't naturally receive sunlight, they could be signs of large-scale terraforming or climate regulation technologies. This is a level of civilization that would rank at least Type 1 on the Kardashev scale. A civilization that harnesses the full energy output of its home planet. But how did Webb pick up something so faint? The James Webb Space Telescope has revolutionized our view of the cosmos with its infrared capabilities, allowing it to peer through dust clouds, detect exoplanet atmospheres, and observe the earliest galaxies. For Proxima b, Webb used a technique known as secondary eclipse spectroscopy, measuring light from the planet when it passes behind its star. This allows astronomers to isolate and study the light that comes from the planet itself, rather than its star. If that light contains signs of narrow-band emissions, like those from LED-style lighting systems, it's hard to explain them without invoking some kind of technological source. Unlike natural thermal radiation, artificial lights concentrate their energy in specific wavelengths, which can stand out to instruments like Webb. Adding to this, Researchers also noticed subtle changes in the planet's thermal signature, suggesting that energy is being distributed unusually across the surface, possibly through technology. There's even speculation about waste heat, a telltale sign of industrial activity or advanced computation. Of course, many scientists are urging caution. These patterns could, theoretically, have natural explanations, such as highly reflective minerals, unexpected geological activity, or as yet unknown atmospheric interactions. But even so, this observation is already transforming the conversation. To confirm or refute these findings, scientists are calling for follow-up studies using next-generation observatories. These include the Extremely Large Telescope, ELT, Habitable Worlds Observatory, HWO, and the LUVOIR, Large UV Optical Infrared Surveyor, mission, all capable of much higher resolution imaging of nearby exoplanets. Many of these telescopes will use coronagraphs to block out a star's light and directly image the planet. Others will employ star shades, massive, sunflower-like spacecraft that fly tens of thousands of kilometers in front of telescopes, blocking starlight with astonishing precision. This will allow us to see the planets directly, not just infer their existence through light curves or wobbles. With these tools, we may finally get a clear image of Proxima b, a visible disk, perhaps even weather patterns, continents, oceans, or, most tantalizingly, evidence of infrastructure. What if we saw roads? Or lights changing with seasons? Or something unmistakably artificial, like geometric structures or atmospheric pollutants that shouldn't be there naturally? This level of observation is not far away. Experts believe that within the next 2 decades, we will be able to scan the atmospheres of dozens of Earth-like exoplanets in unprecedented detail. We're not just searching for life, we're scanning for its fingerprints. Biosignatures like methane, ozone, nitrous oxide, or industrial chemicals like CFCs that could only exist through intelligent activity. If these elements are found together, especially in the right combinations, it will be strong, perhaps definitive, evidence that we are not alone. We may be witnessing the dawn of comparative exoplanetology, where planets are not just distant points of light but actual worlds with unique ecosystems, atmospheres, and possibly civilizations. Imagine the reaction if we confirmed intelligent life just 4 light-years away. It would shake every branch of science, religion, and philosophy. Every textbook would be rewritten. Our place in the cosmos would shift overnight, from being isolated observers to part of a larger, more mysterious galactic community. But this also leads to profound ethical and philosophical questions. Do we try to communicate? Do we wait and observe? Or should we prepare for contact, knowing full well that our definitions of civilization, consciousness, and technology might not align at all? For now, Proxima b remains silent, its lights glowing in the vast darkness of space. Whether they are signs of alien cities or a misunderstood natural process, they push us closer to the answers we've been seeking for generations. This is a moment of scientific curiosity, yes, but also one of wonder, humility, and preparation. The universe has whispered something to us. We just have to keep listening. And as always, we at Waves Discovery are here to explore these cosmic riddles with you. If you're as fascinated as we are, make sure to like, subscribe, and hit the bell icon so you never miss another interstellar insight. Until next time, keep watching the skies.